Hi, good evening, everyone. Kelkao, can you hear me? Whoever is present, can you guys please acknowledge? Ishida, Danesh, can you hear me? Srinidhi, Sunil, can you hear me? I hope you guys can hear me and welcome to the session. Yes, okay. Hi, Ishida, and hi, Srinidhi. Srinidhi, I hope you can hear me also. Can you please acknowledge? Can you please put that in the chat if you can hear me? Okay. Anyway, it's almost time. It's 7:05. So we will wait for 1 more minute for others to join. And once your friends have joined, we will start the session immediately. Yeah. Welcome, Akshat. Hi, Akshat. Can you hear me? I hope, Akshat, you can hear me. Yes. Okay. Akshat, yeah. Akshat has left. So we'll wait for a minute and then we will see who all are joining. And then according to that, we will start the class immediately. Okay. Just give everyone a minute. Srinidhi and Ishita, please wait. Okay. Yeah. So anyway, let's start with the session. So the first chapter that we have in grade 8, right? So good evening, Srinidhi. Good evening. Yeah. So good evening, everyone. Once again, welcome to the session, Manorama Horizon's revision classes for class 8. So my name is Abdul Had, as you can see there on the screen, and I will be taking you the first 4 chapters, okay, as a revision, and that includes rational numbers and linear equations and quadrilaterals, understanding quadrilaterals, and then I think it is data handling. So it's a combination of 4 chapters, and today will be the first chapter, which is rational numbers. I hope you guys know this chapter. You are familiar with the chapter name also. Welcome, everyone. Welcome to all who have joined just now. Hi, everyone. Amreen, Johan, Srinidhi, Akshat, Adit. Yeah. So welcome, everyone. Namaste. Yeah. Akshat. Hi, namaste, Akshat. And I hope you guys will be interactive. Like you can put everything on the chat. Hi, Gauri. And you can put all the doubts and everything on the chat box itself. Okay. And if there is time, then I will turn the audio also on for you guys so that you can talk. So for the time being, let me just start with the topic, rational numbers. And once we are in some detail about that particular chapter, then I'll unmute you guys. And one by one, you can ask all your doubts. Okay. So can we start the session? And Gina, Jude, Sibia, Daniel. Yeah. So welcome everyone once again. So the first chapter here for you guys, it's rational numbers. As you all know that it is rational numbers, and it is a very important chapter, right? It is a basic chapter that you might have studied in grade 7. In grade 7 also the same chapter was there. So this is a continuation of what you have learned in the previous years, 7th, 6th, 5th. So in all the previous years, you might have learned this particular chapter, right? So let's have a quick look at what all our rational numbers contain and what are the important things that we have to remember in rational numbers. Okay. So first thing is, what is an introduction? An introduction, any class or any chapter that we start with, there will be always an introduction to that particular chapter, right? So what is a rational number is what I'm going to tell about in this slide. What is a rational number? You know, you have studied about different types of numbers, right? You have studied odd and even numbers. Yes. Then you might have studied prime and composite number. Yes. I hope you have studied prime and composite number also. Then in grade 7, you might have studied about integers, right? So these were the different number systems that you have studied. Not only integers, you might have studied decimals, right? You might have studied decimals. Then you might have studied fractions also. So these were the common things that you have studied till grade 7th, right? So now when coming on to grade 8th, you have something new. And what is a new thing? This is nothing but the rational number. You have heard that word in grade 7 also, but let's keep it for this year as a new topic. That is, what is a rational number? What is a rational number? You know that. There are around 15-20 people out here in this participants. So at least 90% of all you guys should know what is a rational number. Can you guys put that in the chat? What is a rational number, or how will you define a rational number? Just a basic definition. How will you define a rational number? Can you put that in the chat? I'll check the messages. Okay. So what is a rational number? Any idea? So you know odd and even, you know prime composite. I got a message, Srinidhi, numbers written in the form, all kinds and form of numbers, Gauri. No, all kinds and forms of numbers is not a rational number. Integers and fractions together is rational number. That is okay. Okay, who has told that? Anamika. Yeah, Anamika told integers and fractions together is rational number, and told that a number in the form p by q where p and q are integers and q not equal to 0. So I got one definition. Decimals. Gauri told decimals. Then Isabel told the form p by q. So I got a mix of everything. I got a mix of what all you guys know and what all some people know the exact definition also, right? I think the exact definition was put by Gina. Okay, and very good. A number which is of the form what? So how do you define a rational number? A number which can be written in the form what? Which can be written in the form p by q, which can be written in the form p by q. Okay, that is, p by q is nothing but a fraction, but there is a condition. What are the conditions? P and q are integers. P and q should be integers, and q should not be equal to 0. That is, our denominator should not be equal to what? 0. Yeah. So p by q, I got all the answers. Yeah, very good, everyone. Your feedback is great. Okay, all of you guys, please keep this energy for the entire session. Okay, don't drop your energies. Please keep that in same energy and put all the doubts and all the answers in the chat itself. And any questions that you have also, you can put that in the chat. Okay. So what I was telling was any number which can be written, any number that can be written in the form p by q, and p and q are what? Integers, and q not equal to 0. So there are three things. What is the first thing? To be a rational number, it should be of what form? P by q form. Second thing is, the p and q should be what? Integers. That is the second main thing. And what is the last one? The denominator should not be equal to 0. Q not equal to 0. Only if these three conditions are satisfied, only if these three conditions are satisfied, you can call a number as what number? A rational number. If you want to call a rational number, it should be p by q form, first one. Second one, p and q should be integers. It should not be a decimal. Okay, it should not be a fraction. It should be an integer itself. And the denominator should never be a 0. Okay, so if I write a number 5, is 5 a rational number? Is 5 a rational number? Simply, I'm writing a 5. Okay, is 5 a rational number? Gauri, yeah. Yes, I got an S, no, S. I think I'm getting mixed answers. Yeah. So I'm getting mixed answers for 5. Okay. So if I write simply 5, 5 is not in the p by q form. Is it in the p by q form? Look at this. No, it is not in the p by q form. Simply I'm writing it as 5. It is not p by q form. So I have to write 5 as what? 5 by 1. Good. Very good. So I think Gauri, yeah. Gauri has told that 5 should be written as what? 5 by 1. So only if I write 5 as 5 by 1, this 5 by 1 is in which form? P by q form. And what is P? P is the 5, the numerator. And what is Q? That is the denominator, 1. Look at P and Q. Are they integers? They are integers, right? They are not decimals. They are not fractions. They are pakka integers. So if they are integers, now what is the last thing? Q not equal to 0. Look at the denominator. Is the denominator equal to 0? The denominator is equal to 1. So the denominator is not equal to 0. So all three are ticks. All three are green lights. Yes. So if all three are satisfied here, then you can definitely call this as a rational number. Okay. Srinidhi, yeah, it is an integer also. 5 is an integer. That is okay. That is the basic definition that you can give for 5. Or minus 5 also is an integer. But when we talk about rational number, when we have to say it is a rational number, that means we have to write it in which form? P by Q form. So when you write it in the P by Q form, then you have to look for the second condition. That is, P and Q are what? Integers. Second condition. And what is the third condition? The denominator should not be equal to 0. Clear? So 5 is a rational number. So can we write 5 is a rational number? Yes. So 5 is a rational number. Understood? Can you guys write it down? Any doubts, you can put it here in the chat itself. Please write this down. Please write the important points and the definition also. Okay. When you write, always write with boxes or so it can't come like 8 by 8 or 2 by 2. Like, can the numerator and denominator be the same? Yes, the numerator and denominator can be the same also. There is another thing, Ishida, that I think you will be learning in grade 9th. Okay. That is when you have a numerator by denominator form, and if they have more than one factor. Suppose if I write 5 by 3. 5 by 3 means what is the common factor? 5 and 3 common factor is 1 only, right? What is the common factor? 1 only. Is there any other common factor other than 5 by 3 for 5 and 3? No. So since there is no other factor other than 1 for 5 and 3, that means they are co-prime numbers. Such numbers are called by the name, what numbers? Co-prime numbers. So only when these co-prime numbers are there, we can write it in P by Q form. Okay. So when I write 2 by 2, they have common factor 1 and they have common factor 2 also. When I write 8 by 8, they have common factor 1 and 8 also. So that means they have more than one common factor. So whenever we write, we have to write it in which form? We have to write in the lowest form. Okay, in fractions, for example, I can write our question 5 by 1 as 10 by 2 also. But 10 by 2 is not the lowest form. Is 10 by 2 the lowest form? No. 10 and 2 has factors. Which all factors are there? 2 and 1. So that is not the lowest form. What is the lowest form? 5 by 1. Okay. So only when you write that in the lowest form, you can apply this condition. Okay. Understood? Who asked me the doubt? I think Sriniti Ishida. So Ishida asked a very good doubt. So the numbers have to be co-prime, or the numbers should be in the lowest form. The fraction should not be simplifiable. Like you should not be simplifying it again. Okay. So the fraction should be simplified to the least value, and then you can say that it is a rational number. Clear? And Srinidhi, this is an integer also. This is an integer. 5 is an integer. Okay. So I will tell about that later. In the next slide, I will tell you. Okay. So everyone understood this page, this slide? Introduction, just an introduction to rational numbers, nothing else. Okay. Okay. So can we move on to the next one? So there are different properties that we have to study, and the important properties are: the first one, closure property. You might have studied that. You might have heard that at least. Commutativity, associativity, distributivity, and roll of 0 and roll of 1. So these are very important and basic properties inside your textbook. Now, this is nothing new to you guys, right? So this is everything exactly from what is there in your textbook. So you have different properties: closure, commutativity, associativity, distributivity, roll of 0 and the roll of 1. And this is not the first time that you're learning this. You might have studied commutativity in numbers, in integers or decimals last year also, right? In maybe 6th or 7th also, you might have studied the same thing for commutativity, associativity, distributivity. Yes. So the same thing, how will we apply that in rational numbers? So let us look at the first property. What is the first property? Closure property. Okay. Before going on to the first property, I want to ask everyone a question. Okay. Is 0 a rational number? Is 0 a rational number? Akshat told me that it is no. Okay, very good, Akshat. I'm not saying the answer is no or yes. I'm just reading out the names. Okay, Johan. Okay, no and no. So I'm getting answers. All the answers are no, 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 no. Okay. Yes, Anamika has said yes. Abraham has said no. Yeah, 0 is neither an integer nor a rational number. Srinidhi has said that. Explanation. Very good, Srinidhi. Okay. So is that it? Is there anyone else typing any of the answers? Can I move on to the answer part? What about 0? Is a rational number or not? Isabel, yeah, yes. Okay. So 0, when I write 0, 0 is simply 0 itself, right? But can I write 0 as 0 by 1? Yes. Can I write 0 as 0 by 5? Can I write it as 0 by 10? Can I write as 0 by minus 100? Yes, I can write 0 as 0 divided by any number, right? Can I write 0 as 0 divided by any number? Yes. But what is not possible? 0 by 0 is possible? No, this is not possible. This thing is not possible. Okay. But other than zero, I can put anything. I can put 1, I can put 5, I can put 10, I can put -100 or anything, right? Why? Because 0 divided by, for example, when you divide 0 by 1, 1 into what number is 0? 1 into dash is 0. 1 into 0 is 0. So what about the quotient? It is 0 itself, right? So when you do normal division, 0 by 1, the quotient will be how much itself? The quotient will be 0 itself, Isabel. Understood? So that is not only for 0 by 1, 0 by 5 also. 5 into which number is 0? 5 into 0 is 0. So quotient is 0. Then again 0. So that means the quotient will be 0 for all the cases. It will be 0 by 5, it will be 0 by 100 or 0 by -1000 or 0 by -1 lakh or any bigger number that you put in the denominator other than 0 by 0. You cannot put this. Okay. Always remember, you cannot put 0 by 0. Other than 0 by 0, you can put anything. Okay. If you put anything, that will be definitely equal to what? 0. So 0 divided by any non-zero number is what? 0 itself. 0 divided by any non-zero number will be definitely 0. Okay. So if I write 0 as 0 by 1, is this in the P by Q form? Yes, that is okay. And P and Q are integers. Look at the numerator and denominator. 0 is an integer. Yes. 1 denominator is also an integer. Yes. So you have two integers in the numerator and the denominator. Now, which one is not equal to 0? Numerator or denominator should not be equal to 0? The denominator should not be equal to 0. So that means when you look at the denominator, it is 1. Is the 1 equal to 0? No, it is not equal to 0. So what is also satisfied? The Q not equal to 0 is also satisfied. So that means all the three conditions are satisfied. So is 0 a rational number? Yes, 0 is a rational number. Clear? So 0 is also a rational number. 0 is not a rational number is a wrong answer. 0 is a rational number, and this is the explanation. Okay, 0 can be written as 0 by any non-zero number. So non-zero number means that has a very important significance there. You cannot put denominator 0. Don't put denominator 0. You have to put it as any other number other than 0. It can be positive, it can be negative, it can be anything. Understood? Any doubts? Anyone? Understood? Those of all of you have understood. Can you put that in the chat box with a thumbs up? Okay, very good. Yeah. Please put that, please write it down also. 0 is a rational number. Okay, 0 is what? A rational number. Very good, very good. Everyone, please write it down. Yeah. Please write it down, everyone. Please write it down. Please make it fast. Okay, we have a lot to cover. All the properties, closure property, commutativity, associativity, all these properties are also there. Yeah. So once you guys are done with it, I'll move on to the next slide. Can you please write it fast, everyone? And any doubts? If those of you have not understood anything that I have told, please put that in the chat. Okay. Okay. So I'm just moving on to the next slide. Those of you have not written this, please take a screenshot also and keep it. Okay. Yeah. So I'm moving on to the next page. Closure property. So about the properties that I told you, the first property is nothing but the closure property. And what is the closure property? If you add any rational number, if you add any two rational numbers, okay. So if I take two rational numbers, for example, 1 by 3 and 2 by 5, can I add 1 by 3? A plus B is equal to another integer, Gauri. I would just write 5. It is a rational number. Yeah, and you can write it as 5 also. It is a rational number. Okay, that as I told you, I will come back to that in the upcoming slides about integer and rational numbers. Okay. A plus B is equal to, Gauri told that A plus B is equal to another integer. Okay, let me just give you an example. If I take two rational numbers, 1 by 3 and 2 by 5, 1 by 3 and 2 by 5. When I'm adding these two, how can I add 1 by 3 and 2 by 5? Taking LCM. So when you take the LCM, you can write it as 5 plus 6 by 15, right? What is 5 plus 6 by 15? Is 11 by 15. Very good. Those of you have got the answer using LCM or cross multiplication. You can do that in your own way. Okay, I won't tell you to do only by LCM. You can do that by cross multiplication, or you can do that by taking the LCM. Both are going to be 11 by 15 only. Understood? Can you Guys, check the answer whether you got 11 by 15 after adding 1 by 3 and 2 by 5. Please check. Yes. Okay. So is 1 by 3 a rational number? Yes. 2 by 5 another rational number? Yes. And the sum is 11 by 15 another rational number? Yes. So that means when you add two rational numbers, you are going to get another rational number. Such property is called as what property? The closure property. When you add something of a similar type and you are getting the same type again, such properties are termed under the bracket, which one? Closure property. Such properties can be called as the closure property. Clear? So here it is following the closure property. When you add two rational numbers, when you add two rationals, what are you getting? You are getting another rational number. Okay, you are getting another rational number. Same goes for what also? Not only for addition, it goes for subtraction also. If I subtract 1 by 3 minus 2 by 5, I'll be getting 5 minus 6 by 15. That is minus 1 by 15. Is minus 1 by 15 a rational number? Please do that and check. Is that a rational number? Yes, that is also a rational number. So not only addition, subtraction also. In subtraction also, what you will be getting? You will be getting rational number. So what is followed there? Closure property is followed there. Clear? Any doubts in this? Closure property is followed in addition as well as subtraction. When you multiply 1 by 3 into 2 by 5, it will be 2 by 15. Another rational number. So you multiply two rational numbers, you will get a third rational number. That is also closure property. Now, when you divide 1 by 3 divided by 2 by 5, what is 1 by 3 divided by 2 by 5? 1 by 3 into 5 by 2. That is nothing but 5 by 6. Again, you are getting a rational number. So division is also what? Under the closure property, or the division is, or you can write it as rational numbers are closed under division. What you can write? Rational numbers are closed, because it is closure property, we call it as closed. So rational numbers are closed under the property, which one? Division. Not only under division, it will be closed under addition, subtraction, and multiplication also. Clear? Any doubts? Anyone? This is a simple property. Closure property is a very easy property. The beginner level property in your textbook. Okay. So understood closure property. Two rational numbers added, subtracted, multiplied, divided. You will get another rational number. Clear? Can we move on to the next one? Next property. Please write it along with me also, okay? Because we don't have much time. So please write it along with me when I'm writing here on the whiteboard. And if you have not understood that, you can ask me in the chat box. Clear? Okay. Yep. So I'm moving on to the next slide, which tells about the commutative property. What is the next one? The commutative property. What does this commutative property tell about? You know that commutative property is nothing but a plus b should be equal to what? B plus a. That is, when you take two numbers, you should be able to add them in any order. You should be able to add them in any order. That is, 1 plus 2 is also 2 plus 1, right? If I take 1 plus 2, that is same as 2 plus 1. But here we are not talking about integers. Here we are talking about what? Rational numbers. So when I take two rational numbers, 1 by 3 and 2 by 5. What is 1 by 3 plus 2 by 5? When you cross multiply, you will be getting 5 plus 6 by 15. That is 11 by 15. Now, I'm changing the order. I'm writing 2 by 5 plus 1 by 3. What is it? That is also 6 plus 5 by 15, which is nothing but 11 by 15. So when you take two rational numbers and if you add them in any order, the answer will be the same. So that means you can call what? Rational numbers are commutative. That particular property is called as the commutative property. So rational numbers are commutative under which one? Under addition. We have done addition here, right? So when you take two rational numbers and you add them, you can add that in any order and you will be getting another rational number. So therefore it is what? It is commutative under addition. Clear? Any doubts? Anyone? Please put your feedbacks in the chat. Okay, I told in the beginning, please don't drop your energy in between. Otherwise, the whole class will be sleeping. I will also be sleeping, and it will be very boring. Okay, so please put your feedbacks. Please put that in the chat. Even if you have not understood, also please ask me again and again. Okay, or if you want to ask anything other than this chapter, also you can ask. If time is there, I will clear that doubts also. Okay, yeah. So don't drop any of your guys' energy. Please keep it till 8 o'clock, and after that you can sleep or you can do whatever you want. Okay. Okay. So let us move on to the next one. That is in commutative property, we checked addition. Now, what about subtraction? If I take 1 by 3 and subtract with 2 by 5, I will be getting 5 minus 6 by 15. That is minus 1 by 15. Now, if I take the reverse, that is 2 by 5 minus 1 by 3. What is it? It is going to be 6 minus 5 by 15. That is not minus 1 by 15. That is 1 by 15. So here I got minus 1 by 15. Here I got 1 by 15. Are they same? They are not same. So that means is subtraction commutative? Subtraction is never commutative. You know that, right? You all know that subtraction was never commutative in 6th standard or 7th standard or 5th standard also. It was always not commutative. That is, you cannot subtract two numbers in your own wish. If you want to subtract 5 and 2, you have to subtract it 5 minus 2 and you will get 3. And you cannot take 2 minus 5 and you will never get 3 there, right? So that means rational numbers are not commutative. Rational numbers are not commutative under subtraction. Clear? They are not commutative under subtraction. Understood? Clear? This property is clear, easy. Commutative property itself, we are talking about subtraction inside that. So in subtraction, when you do commutativity, it is not following that particular property. And now when I talk about multiplication, for example, 1 by 3 into 2 by 5, what is it? It is 2 by 15. Now I am changing the order, 2 by 5 into 1 by 3. That is also 2 by 15. So are you getting the same answer when you change the order? Yes. So that means multiplication is commutative? Yes. So multiplication is commutative. So I can put a tick for multiplication. Now, can you guys check for division? Can you guys check for 1 by 3 divided by 2 by 5? And also, can you guys check for 2 by 5 divided by 1 by 3? Can you guys do that? Can you do that on your own? And please put the answer in the chat. Please put that. What is first one? Find out what is 1 by 3 divided by 2 by 5. Who is going to find out that answer? Please, 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 please. Fast, 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 fast. 1 by 3 divided by 2 by 5. What is the answer? What is the answer? Please put that in the chat box. 1 by 3 divided by 2 by 5. It will be 5 by 6. Yeah, Srinidhi. Very good, Srinidhi. Very good, very good. Now, 5 by 6 is the answer for the first part. Okay. Now, what is the next one? 2 by 5 divided by 1 by 3. Can anyone do that and tell me the answer for the second part? 2 by 5 divided by 1 by 3. It will be 6 by 5. Very good, Adit. Very good. So 6 by 5. Is that same? No. One is 5 by 6 and the other one is 6 by 5. So is division commutative? Division is also not commutative. You cannot divide in your own wish. Okay, you have to divide A by B, you will get one answer. When you divide B by A, you will get another answer. So that means division is never commutative. Division is never commutative. It was not in integers. It was not in rational numbers only. It cannot be commutative in integers, or it cannot be commutative in decimals also. Okay. So can we move on to the next property? Very important property is commutative. Okay. So I hope you all understood this one. Any doubts? Anyone? Can I move to the next one? Yes. So the next one is the associative property. What is the next property? The associative property. What is associative property? In addition, when I take three numbers, A, B, and C, I should be able to add them in what? A plus B plus C. That is A, then added with B plus C. That should be same as A and B added together and then adding with C. So this is the property called as associative property. That means this is about addition. Okay, this is not about division or subtraction. This is only about addition. So when I take three numbers, okay, 1 by 3, I'll take same denominator for easy calculation. So 1 by 3, 2 by 3, and 5 by 3. I'm taking three numbers with the same denominator so that our answer will be easy to find. Okay, what is the first one? 1 by 3 plus, what is this bracket? 2 by 3 plus 5 by 3. And here what will come? 1 by 3 plus 2 by 3 plus 5 by 3, right? So here 2 by 3 plus 5 by 3 is nothing but 7 by 3. Here 1 by 3 plus 2 by 3 is nothing but 3 by 3. So 3 by 3 plus 5. Here how much? Here you will be getting 8 by 3. And here also you will be getting 8 by 3. Both are equal? Yes. So that means you are getting A plus B plus C is equal to A plus B plus C. Clear? Understood? So when that kind of property, what do we call it? We call it as the associative property. That means rational numbers. We can write rational numbers are associative under which one? Addition. The rational numbers are associative under addition. Clear? Only under addition. Okay. I'm not talking about subtraction or division or multiplication. So rational numbers are associative under addition. Now, what about subtraction, multiplication, division? Are they associative? Same like commutativity. Same like commutativity. Subtraction was commutative in the rational numbers? No. So here also addition is commutative. Sorry, associative. Subtraction, when you talk about subtraction, it is not. And when I talk about multiplication, multiplication is also associative. That is, A into B into C will be equal to A into B multiplied with C. That is, A multiplied by B into C will be same as A multiplied by B, the whole multiplied with what? C. So that means this is associative. Multiplication is also associative. Now, when you talk about division, can you divide three numbers in any order? A divided by B divided by C will never be equal to what? A divided by B divided by C, unless it is what? Unless it is all same numbers. Okay, unless it is all the same numbers, the answer will not be equal. In that case, it can change, it can differ. Okay, but for the time being, let's understand that it's not associative. Division is also not associative. Clear? Any doubts in associative property? Okay, so can we move on to the next one? Okay, so the next one is a distributive property. You know that distributive property. What is a distributive property? If I take a number A and then multiply it with B plus C. Okay, if I take a number A and then multiply with what? B plus C. What is A into B plus C? Can you guys put in the chat if you know that? Those of you who know that what is the answer for A into B plus C, what will be A into B plus C? Please put that in the chat fast. Those who have not put the answers before, can you please type type the answer for A into B plus C? What is the answer for A into B plus C? What is A into B plus C? Please put the answer A, B plus AC. Has told an answer A, B plus AC. Anne has told an answer A into B plus A into C. Adit has told AP plus AC. Anamika, AB plus AC. Very good. A into B plus A into C. Srinidhi, yeah, very good, very good. So everyone is saying the same answer. So I should not be changing that, right? Because you guys know what is A into B plus C. So what is A into B plus C? It will be A into B plus A into C. Understood? It will be A into B plus A into C. This property can be used very effectively in many questions. For example, if you have 5 into 106, what is 5 into 106? You can also write 5 into 106 as what? 100 plus 6. Now, what is 5 into 100? 500. 5 into 6? 30. So, what will be the answer? 530. Okay, so this can not only be used on rational numbers, it can be used on integers also. It can be used in decimals. It can be used anywhere. It can be used effectively in many types of questions. Okay, so what is A into B plus C? It is A into B plus A into C. And the same property goes for A into B minus C also. What is A into B minus C? It will be A into B minus A into C. Clear? The same property goes for distributive. This property is called as a distributive property, right? You are having a multiplication outside. You are having a multiplication outside. And inside you have addition, or sometimes you have subtraction. But what will happen when you multiply with addition? What will happen? It will become A into B plus A into C. When you multiply with a subtraction or with a difference, B minus C, it will be A into B minus A into C. Clear? So this is the distributive property. And this does not limit with 2 numbers or 3 numbers. For example, if we have A into B plus C plus D minus E plus F minus G, there also you can write as AB plus AC plus AD minus AE plus AF minus AG. So there also you can apply. Clear? So it is not only limited to 2 numbers or 3 numbers or 4 numbers. It can be applied to any number of numbers. Clear? So please write it down. Please write the distributive property. Everyone, please, fast. Any doubts? If you guys have, please put that in the chat also. If there are any doubts you guys have, please put that in the chat. Yeah. Please keep the energy as I told you in the beginning itself. Don't drop off your energies. It's because Max is a boring subject for many people, right? For me, it is not boring. I'm not saying that Max is boring for me, because as a math tutor, I should never be saying that Max is a boring subject, right? So for those of you who love mathematics, can you put that in the chat? Who all loves mathematics? It's a nice subject. Yeah, so it's a very nice subject, right? There are some tricks and tips which we can use in mathematics, and you will get good marks. And also, I think, likes the subject. Those who like the subject mathematics, please put a thumbs up here. I just want to see the count, how many people like mathematics. At least by the count, we can understand that, okay, this many number of students, or those of people, it's cool but hard sometimes. Gauri, yeah, that's correct. Sometimes it's cool, right? For addition, positive numbers, it is cool. But when it comes to negative numbers, we always find it difficult, right? Ishida also likes the subject. what about the boys? What about the boys in this chat? Akshat, yeah, sometimes it's very interesting. Very good. Yeah, Akshat. It's when you get the right answer, it's always interesting, right? When you get the right answer and when you get good marks in the exams, it's an interesting subject. And when some hard chapters are coming, suppose you might have studied the chapter interest, a simple interest and compound interest, right? For some people, it may laterals also okay kind of chapter. When you fail, you won't like it much. Yeah, yes, Gauri. Sometimes confusing. Yeah, Abraham. Sometimes it is confusing. But there is always an advantage of mathematics which no other subject has, right? If you study addition of rational numbers, you can apply that in any number of questions, right? You can apply that in hundreds of questions. You can apply that in any type of question which is coming as an addition of rational number or subtraction or commutativity. When you study one thing, you can apply that in n number of questions. There is no limitation for that, right? That is one advantage of mathematics, I feel, that we have when we compare with physics or chemistry or other science subjects or history or whatever. So in all those subjects, I think you have to learn something new in every chapter. But here, some things are repeating. You studied addition in grade second standard or third standard, but still you are using it. So that means mathematics was useful from there. Like what you studied in grade second standard or third standard is still useful, right? So one time you study something, it will be useful in many places. Clear? So that is what I feel about mathematics. It can be confusing at times. It can be boring. Some classes, like particularly after the lunch break, if there is a maths class and if there is a very boring chapter and if the teacher is teaching in a very boring way, then it will be very boring. That time it will be boring. Otherwise, it's one of the easiest and most used subject. Like you can use it anywhere, right? You can use that to divide a paper into 5 pieces. You can just take a scale and you can divide that into the different lengths and you can divide that. Yeah. So I'm not taking much time. So distributive property, you guys understood, right? Okay. So what is the role of zero? What is the role of zero in any number? You add a number with zero, you subtract a number with zero, you will get the same number. You take 5, you add what? And you will get 5. You add 0. Yes. So you add 0 with any number, you will be getting what? That particular number itself. For example, if I take minus 100, you add what? You will get minus 100. You add 0. And we are talking about rational numbers. So I'm putting a rational numbers 2 by 9. So 2 by 9 also, what should I add with? I should add 0 and then only I'll be getting 2 by 9. So 0 is also called as, somebody was putting in the chat box. Yeah, Anne and Sweetie. 0 can also be called as the additive identity. 0 can also be called as the additive identity. Clear? Identity means something that doesn't lose its value when you are adding or subtracting it. Does 5 lose its value when you add with 0? No, it is 5 itself. It does minus 100 lose the value when you add with 0? No. So that means the identity is maintained. That is why we call it by the name additive identity. Okay, additive identity will be something which when you add with a number, you will be getting the same number. When you subtract with a number, you will be getting the same number. This is not only for addition, you can subtract also. For example, you take 50. You take 50 minus 0, also what? It will be 0 itself. Clear? Understood? So that is about additive identity. I won't call it a subtractive identity because that is something which has a contradiction. I will tell you about the contradiction later. Now, if I talk about subtractive identity, this class will go on to till 8:30, 9 o'clock. Okay. So I'll just limit it here. What is 0? 0 is nothing but the additive identity. Any number, for example, if you take a number A and then you add with what? You add with 0, you will be getting A. Same like that. If you take P by Q, you have to add with what? 0, and then you will be getting P by Q. Clear? So that is why we call it specifically as an additive identity. Additive identity. Clear? Everyone, please write it down. Role of 0. What is the role of 0? You add it, you will be getting the same number. You subtract it, you will be getting the same number. Okay? Yes. Now, I'll just, for a very small hint, I will tell you why it is not subtractive identity. For example, 5 plus 0 is also 5. 0 plus 5 is also 5. So that is why 0 is what? Additive identity. But when you talk about minus 2, okay, minus 2 minus 0, I'm subtracting, okay. or not minus 2 minus 0. I will take 2 minus 0. What is 2 minus 0? 2. But if I change the order and write 0 minus 2, is that 2? No. So you are getting a different answer? Yes. So that is why we call only additive identity. We won't call it as what? Subtractive identity. Why subtractive identity is not possible? You subtract 2 minus 0, you will get 2. But when you subtract 0 minus 2, it is not commutative. You cannot do in any order. Here it is possible, but here it is not possible. Clear? Understood? Understood this property, why it is not subtractive identity? Now don't go and ask your teacher why subtractive identity is there. I have told you the answer. Subtractive identity is not there because you can write 2 minus 0 is equal to 2. But you cannot write 0 minus 2 is equal to 2. 0 minus 2 is never 2. 0 minus 2 is minus 2. So that is why what is not there? Subtractive identity is not there, but only what is there? Additive identity is there. Clear? Understood? Yes. Now, what is the next one? The role of 1. 1 is a very important number, right? Same like addition and subtraction. When you multiply, when you take 5 and you multiply something with 5, how much? Multiply something with 5 and you get 5. What is that something? That something is nothing but 1. So 1 is also called as the multiplicative identity. 1 can also be called as what identity? Multiplicative identity. Okay. 5 into 0 is 5. Is 5? No. 5 into 0 is how much? 0. So this is not, 0 is not the multiplicative identity. Who is the multiplicative identity? 1 is the multiplicative identity. You take minus 1 by 3. You multiply with 1, you will be getting minus 1 by 3. So identity, who is maintained? The value is correct, same, right? The value, the number does not lose its value. So if a number is losing its value, it is not an identity. So here when you multiply with 1, you are going to get what? The same number, right? So that is why we call it as multiplicative identity. Now, for example, division, 5 divided by 1. What is 5 divided by 1? 5. So is that also division also possible there? 1? Yes. When you divide a number by 1, you will be getting what? The same number. But what is not possible? 1 divided by 5. Is 1 divided by 5 1 by 5? Yes. That is not 5. So these two are equal? No, they are not equal. So what is not there? It cannot be called as division identity. This is not division identity. This is what identity? Multiplicative identity. This is what identity? Multiplicative identity. Clear? Everyone understood? Please put that in the chat box if you have understood or not. So what is multiplicative identity? Any number that when we multiply with a particular number, we give you the exact number. So what number gives the exact number? Only 1 can give you the exact number. If you multiply with minus 1, you will not get the same number. If I multiply with 10, you will not be getting the same number. Only when you multiply with 1, you will be getting the exact same number. And that is why we call it by the name multiplicative identity. And division identity or dividing identity is also there, but only when you take 5 by 1. When you take 1 by 5, it is not coming as 5. It is coming as some other number. So that means division identity, you cannot call it by that name. You can only call it by the name multiplicative identity. Clear? Understood, everyone? So what is the role of 1? Multiplicative identity. What is the role of 0? Additive identity. Okay? Yes. So we have some questions here. What is the first question that you have? Find 2 by 5 into minus 3 by 7, minus 1 by 14, minus 3 by 7 into 3 by 5. Can you see this question, everyone? Yeah, please write down the question first. Okay, please always when you get a question, please write down the, I'm not saying to write down the entire word problem or an entire thing there. Please write down the numerical part only, this part. Okay, please write down this part in your notebook. I'll tell you the easy way to do this. This can be done in any way. This can be done directly also. You don't need to have an easy way. It can be done in any way that you like to. Okay, but I'll tell you the better way. So the better way is this one. So if you have this number, you look at the first two. Look at the first two and look at the last two. Okay, look at the first two numbers and look at the last two numbers. What is common in these two? What is common here? Can you see that you have a minus 3 by 7 here and minus 3 by 7 here? Can you guys see that? Yes. So minus 3 by 7 is a common number. So what I will do is, I will take minus 3 by 7 here into. So when I take minus 3 by 7, what is left here? First part, it is 2 by 5. Okay. And when I take minus 3 by 7, what is left here? 3 by 5. So I will write it as minus 3 by 7 into 2 by 5 plus 3 by 5. Can I write like this? Yes, I can. Then what is the middle number, what is this middle part? It is minus 1 by 14. So write it as minus 1 by 14. Yes. So now I can add these two, right? I can easily add 2 by 5 and 3 by 5. No need of LCM because the denominator is same. So I'll be getting minus 3 by 7 into, what is this? 2 by 5 into 3 by 5? 5 by 5. 5 by 5. Minus 1 by 14. So 5 by 5 is 1. So minus 3 by 7 into 1. Any number into 1 is what? That number itself. So minus 3 by 7. Then minus 1 by 14. So you have minus 3 by 7 minus 1 by 14. What is the LCM of the denominator? 7 and 14. 7 and 14. What is the LCM? LCM of 7 and 14. Please tell me the answer for what is the LCM of 7 and 14. What is the LCM of 7 and 14? 7 and 14 is 14 is in the multiplication table of 7 only, right? Yes. So what will be the LCM? It will be 14 itself. So I just need to multiply here by 2. So I'll be getting minus 6 by 14 minus 1 by 14. What is minus 6 minus 1? Because now the denominator is the same, I can subtract the numerator. Minus 6 minus 1, that is minus 7 by 14. Now, this is not the final answer. Minus 7 by 14, I told you in the beginning, you have to simplify it to the smallest value. So what is the smallest value? 7 and 14, you can cancel with 7 and write 1 by 2. And also, don't forget this minus. So what is our answer? It will be minus 1 by 2. Very good. I think some of you guys have already got this answer, minus 1 by 2. Yeah, very good, very good. And those of you did not get the answer, please correct yourself. Okay, please correct and write it as minus 1 by 2 and also write the steps also properly. Okay, don't simply write the final answer and keep it like that. Also write the steps properly. Okay. So that is about the first question in here. So here, what property have I used here? So it's a very important question. What property did I use there? In exam, teachers might ask you, what property is being used here? This is a textbook question, I think. Yeah, this is a textbook question. So what is the property which is used here? And told me that it is distributive. Okay, and told me this distributive. Now, anybody else? Akshat, Anamika, distributive. Adit, commutative. Very good. Srinidhi, distributive. Very good. Please, yeah, please put the properties that you think that is going to be applied here. Akshat also said it is distributive. Gauri said that it is distributive. Udiba said that it is distributive. Yeah. So the property that we have used here is nothing but the distributive property. That is A into B plus C. Right. Look here. Did I take minus 3 by 7 outside? Yes. So this is our A. Who is this? A. Okay. So this is A. Now, what is this one? This is B and this is C. So did I use A into B plus C? Yes, I did use A into B plus C. So I have used what property here? I have used the distributive property here. So if teacher is asking you what property have you used here to find out the answer, it is nothing but the distributive property. Clear? Okay. Can we move on to the next one? Okay. So the next question, find 254 by 105 multiplied with 15 by 127 plus 150 by 169 multiplied with 13 by 15. Now, when you look at this question, first thing is that you need to identify what are the different parts. Can you see the question itself is in two parts? This is one part, yes, and this is the next part. So there are two parts for the same question, right? So the question itself is divided into two subparts. One part over here and another part over here. So let's look at each part one by one. When you look at this part, you can see that 254 and by 104, right? I'll write it again. 254 by 105 multiplied with 15 by 127. Look at this 254 and 127. Are they multiples? When I take 127 and multiply with 2, will I be getting it as 254 itself? Yes. So can I cancel this and write 2 here? Yes, I can. Now 15 and 105. 15 into what is 105? 15 into 7. So when you do 15 into 7, you will be getting 105. So you can cancel this and write 2 by 7, right? So what is this pink? This part is nothing but 2 by 7. Okay, understood? Any doubts in this one? Anyone is having any doubt? Please ask that in the chat. Okay. What I have done here is I have cancelled whatever is common. I have just cancelled directly. Okay. So I got it as 254 by 127. I can directly write it as 2 because 127 into 2 is 254, right? Yeah. Now, when I look at the next part, what is the second part? What I have to take is 150 by 169 multiplied with 13 by 15. So here 15 and 150, can I cancel and write 10? Yes, I can. 13 is 13 into 13, 169. You might have studied squares and square root, right? So in squares and square root, you might have studied that 13 square is 169. So can I cancel this and write 13? Yes, I can. So what is the only remaining numbers here? This will be 10 by 13. Understood? So what is the remaining here? It is 10 by 13. So here I got 2 by 7. Here I got 10 by 13. Now look at what is there in the middle. What is there in the middle? It is a positive. It is an addition. So 2 by 7 plus 10 by 13. I just have to add these two. What is the addition of this one? I can take the LCM or I can cross multiply. I'm just cross multiplying. So 2 into 3, 13 is 26. This one, 7 into 10 is 70. By 7 into 13 is nothing but 91. So what is 26 plus 70? It is nothing but 96 by 91. I can maybe simplify and write it as 1 5 by 91. Also, I can write it as a mixed fraction. Understood? Very good, Anamika. Very good. Yeah, those of you who got 96 by 91, please raise your hand in the chat. Yeah. Okay, very good. Very good. 4, 5, 6. Very good. Very good. Very good. Anyway, I want to see this energy throughout the sessions. Okay, you guys did a very good job. Like we started 1 hour back, and still the same energy I can see in everyone. Even though my throat is almost dried, like after talking too much. Even though my voice is gone, you guys are still in very good energy. Okay, so it's a very important thing. Like you guys are the core or the important part of the class. I'll drink some water actually, no issues. I'll drink after this class anyway. Anyway, I just kept some water here, but I have not got enough time to take a small break or something. So that's fine. Anyway, you guys kept the energy. It's a very good thing. Like I have not seen much students keeping the same energy in the classes. So please keep the same energy throughout all the sessions. Okay, you have tomorrow also one mathematics class, and then next week also Thursday and Friday also you have maths class, right? So we will discuss the important chapters also there. So don't forget to keep the energy. Don't forget to come back also. Okay. And if any of your friends have not joined, please ask also them to join the class. It's a free class, right? So it's a free class. Why your friends also can simply join and see this class, right? Yeah. Let them also get some marks. So let me move on to the next slide. It's a statement. It's a true or false question. Rational numbers are closed under division. Is rational number closed under division? Rational numbers closed under division? False, false. I'm getting the answers false from Mika. Very good. Adrich, very good. And false. Yeah. I'm getting false, false, false. Nobody's telling it true. Why nobody's telling true there? Because it's about rational numbers, it's about division, and it's about the closure. What does closed means? Closed means which property? Closure property. Okay. So closed means we are talking about the closure property. So closure property, division, rational numbers will not be closed, right? Adit said that it is true. Okay, Adit. I think Adit, just for the sake of telling true, or you have any, yeah. Okay. Okay, guys. Anyway, the answer is false. Okay. Even though I just told that nobody is telling true or anything, but the answer is false itself. Because you cannot divide two rational numbers and get a rational number. Right? You can also wait. It was closed under division. Sorry, I did not read the question properly. First of all, so rational numbers are closed under division. Can I take two rational numbers, 1 by 3 and divide by 2 by 5? I'll be getting what? 1 by 3 into 5 by 2. So that means I'll be getting 5 by 6. Is that a rational number? Yes. So rational numbers are closed under division. Okay, I forgot to tell you that in the first slide, I guess. So rational numbers, you can divide two rational numbers and you will be getting another rational number. But this question has two answers. It can be false also. Okay, I'll keep it false also, true and false. Why true and false? Because if I take 0, for example, 5 divided by 0, 5 is a rational number, 0 is a rational number. Is 5 divided by 0 possible? No. So 5 divided by 0 is not possible, or 5 divided by 0 is not coming as a rational number. So the answer can be true for all numbers except 0, or except when you divide by 0. In other cases, it will be true. But if you talk about 0, when you divide by 0, the answer will be false. Okay. So I'm just keeping it for both the answers. It can be true when you take non-zero numbers. It will be false when you take the denominator as what? 0. Okay. Now, every integer is a rational number? Yes. So I think Srinidhi was the one who was talking about every integer. Integers, all integers, right? So that is why when we took 5, five is an integer, minus 10 is an integer, minus 15 is an integer, 25 is an integer, 36 is an integer. So all these are integers. All integers can be written as what? By one, by one, by one, by one. So that means all integers are rational numbers. All integers are rational numbers. Clear? And what is the third one? There are infinitely many rational numbers between two rational numbers. There are infinitely many rational numbers between two rational numbers. Is that true? If I take 1 and 2, are there many rational numbers between 1 and 2? Is there any rational number between 1 and 2? I can write 1.1, or I can write 1.1 as also 11 by 10. I can write 1.2, which is nothing but 12 by 10. I can write 1.5, which is nothing but 15 by 10. I can write 1.65. 1.65 is 165 by 100. So if I keep on writing like this, can I write infinite numbers and which is not countable? Yes, I can write infinite. So this means this part is what? True. So this is second one is also true. Third one is also true. Now, what is the last one? 1, 0, minus 1 are the numbers with their own reciprocals. What is the reciprocal of 1? It is 1 itself, 1 by 1. What is the reciprocal of 0? 1 by 0. What is 1 by 0? What is 1 by 0? What is the next one? Minus 1. What is the reciprocal of minus 1? 1 by minus 1, or that is minus 1. So you can see that 1 is having its reciprocal, 1. Minus 1 also will have the reciprocal, minus 1. But when you take 0, is 1 by 0 possible? No. You cannot divide a number by 0. You cannot divide a number by 0. So when you cannot divide a number by 0, that means it does not have a reciprocal. So 0 does not have a reciprocal at all, right? So this number 0 is not having a reciprocal. Means 1, 0 and minus 1 does not have their own reciprocals. Who all has their reciprocals as the numbers? 1 and minus 1. If I tell only 1 and minus 1, that is correct. But if I tell 1, 0, minus 1, it is not. Okay. So it is the answer is false here, and only which two numbers are having their own reciprocals? It will be 1, negative 1. Understood? Yes. So I am winding up this chapter here, rational numbers. I hope everyone understood all these concepts clearly, right? So I hope all of you who are present in this class and who did not drop any of your energy, stayed until the end of the session. Thank you everyone for joining the session. And I hope you will be there. You all will be there tomorrow also at the same time. 7 o'clock, we'll be having another session, right? Tomorrow. So please join. Please tell your friends also to join. And it's a very important revision class which is going on, right? So if they also get the chance to attend these classes for free, completely it's free, provided by Manorama Horizon, right? So it's a free class. So please ask them to join. And if you have any doubts, as I told you, please put that in the chat box. In YouTube also, if you go and visit the Manorama Horizons channel, you can see the same video. If you have not understood some bit by bit part here and there, you can go back and see those videos, okay? The channel will have the recorded video also there. So you can go and see that. And if you have any doubts, you can put that in the chat box. Okay. And when I'm seeing those comments, I will be replying and you will be getting the answers. Okay. Okay. Anyway, thank you, everyone. Thanks a lot. And we will meet tomorrow at the same time. And let's meet again with the new chapter. I think it's linear equations. I think so. Or maybe quadrilaterals. Anyway, let's see tomorrow. And we will meet again tomorrow with your friends also. Okay, so please don't forget to tell your friends. Please ask someone else to join. It's a free session, as I told you. Please ask them to join. Okay. Anyway, let me go and drink some water, and we will see tomorrow. Thank you, everyone. Thanks a lot. Good night. Yeah. Bye, everyone.